Okay, guys, let's look at section 10.1. We'll start looking at these. Now, in these, it says if any of these problems you solve in this section, feel free to use matrices and row reduction to save time instead of continuing to write variables. I'm going to actually do two variables, um, like elimination. I'm going to do these with elimination as the equations themselves. I'll do matrices with everything else. Okay, so let's look at this. In 10.1a, it says 4x minus 3y equals 28, and 9x minus y equals negative 6. Okay, so if I'm going to do elimination, I want to be able to add these together and get rid of them by having the same number here but different signs, or here. I don't see that right now, so I need to multiply. 4 and 9, I really don't want to do that. But I look at this, if I multiply this by a negative 3, that will make negative 3 times negative 1 is positive 3, which will cancel that out. So I'm going to rewrite these here. I get 4x minus 3y equals 28. That didn't change. Negative 3 times 9 is negative 27x. Negative 3 times negative 1 is a positive 3y equals negative 3 times negative 6 is a positive 18. Yeah, that's right. 4 minus 27 is negative 23x. These are gone, and I get 28 plus 18. 8 plus 8 is 16, carry a 1. 2, 1, 3, that's 46. And if I divide by negative 23 on each side, I get x is equal to negative 2. So there's my x value. To find the y value, I just need to put that into one of these. I'm going to put it into this equation. So I'll go 9 times x, and x is negative 2, minus y equals negative 6. 9 times negative 2 is negative 18. So if I add 18 to each side, negative 18 plus 18, that's gone. And I get negative y equals negative 6 plus 18 is 12. And so y is equal to negative 12. So there's my solution. I could write it as a point, negative 2, negative 12, but I don't need to. Okay? Let's look at another one quick. Part B, does 2x minus 6y equals 10, and then negative 3x plus 9y equals 15. 2, 3, I don't see 6, 9. So I'm just gonna do this. I'm gonna multiply this by a positive 3 and this by a positive 2. I can always multiply by each equation by the other equation's coefficient. That will always make them the same. So check it out. 3 times 2, that's 6x. 3 times negative 6, that's negative 18y, equals 3 times 10 is 30. Okay? 2 times negative 3, that's negative 6x. That means they're going to be gone. 2 times 9 is 18. Whoa. I didn't see that. That's going to be gone. So I end up with 0 equals 2 times 15. That's 30. Oh, this was a negative 15. See it? Negative 15 right there. That makes negative 30. 0 equals 0. That's true. So this has infinite solutions. Infinite solutions. Okay? Now, for infinite solutions, if I want to detail them all, I would take either one of these and I would solve it for, let's say, y. So my solutions might look like x and then some other thing. But on these, we're just wanting to know there's infinite solutions. Okay, so when you eliminate the variables completely and you get an equation that's true like this, 0 equals 0, that's infinite solutions. Let's look at the next one. I suspect it's going to be a no solutions, just because if I was writing it, I would give you one of each just to give an example of each one. And if you look at this system versus this, see how these coefficients are exactly the same other than this. So I would do it the same way. I would multiply this by a 3 and this by a 2. Oh, yeah. Um, there we go. And so that would give me 6x minus 18y equals 30. And I'd end up with also negative 6x plus 18y, gone equals negative 28. And so I end up with 0 equals 30 minus 28 is 2. That's not true, and it will never be true. So there is a no solutions case. Okay, so that's what we're looking at there, guys. That's how we would do elimination every single time. Now let's look at 9 for a second. Next problem. Chemist has two solutions, one containing 4% alcohol, another containing 12% alcohol. How many milliliters of each solution should he mix to obtain 1,600 milliliters that contain percent? This is a mixing problem. Anytime I'm mixing things up, and this is a classic, 4%, 12%, I'm solving for two things. And look at this. How many milliliters of each solution? So I'm going to define my variables. X is the milliliters of the 4% alcohol solution. And I'm going to do y is equal to the, I'm running out of lead in my pencil. Okay, y is going to be the milliliters of, sorry, I'm getting lead quickly. Where is it? There it is. Y is going to be the milliliters of the 12% solution. Okay, so let me get this, and I'll pull that off. There we go. I'm just loading my pencil with lead. Sorry. Delays. There we go. Okay. There we go. So y is the milliliters of the 12% solution. Okay, so, and it tells me how many should I mix to obtain, I got 16 milliliters of a solution. So if I add the milliliters of this and the milliliters of that, I'm going to get 1,600, because milliliters plus milliliters gets me millimeters. Okay, now, but if I do 10% alcohol, 10%, I can multiply percentage times this. That's kind of like a value or a weight times that. And this is 4%. So value or weight or percent times the amount plus 0.12, the value or percent times the amount. That gives me value or percent times the total amount. There are my equations. So I've got x plus y equals 1,600, and I've got 0.04x plus 0.12y equals 0.10 times 1,600. Isn't that 1,600? Isn't that 160? I think so. Yep, 160. Okay. So now I need to eliminate. I'm going to actually just multiply this by minus 0.04. So I end up getting this, a negative 0.04x minus 0.04y equals, what's 0.04 times 1,600? 0.04 times 1,600. 0.04 times 1,600 gives me 64. And so this is 64. Oh, a negative 64, because it was a negative 0.04. Okay, that's gone. 12 minus 0.04 is 0.08y, and that equals 160 minus 64, that's 96. And if I divide by 0.08, 96 divided by 0.08 gives me 1,200. So I need 1,200 milliliters of the 12% solution. And if they add up to 1600, I can easily go 1600 minus the 1200 gives me 400. So this is 400 milliliters, and this is 1200 milliliters. Okay, let's look at the next problem. I expect it's kind of similar because those are popular kind of problems. A fruit stand sells two strays of strawberry. See how it's mixing things? So, and it says a box sells for $7 of standard. A box of deluxe sells for $10. In one day, the stand sold 135 boxes of strawberries for a total of $1,100. So if I'm looking at this, let's go X equals the number of, as it wants to know how many boxes of each type, number of standard boxes. And Y is the number of deluxe boxes. And it told me that in one day they sold 135. So X plus Y equals 135. Whenever you have mixed numbers, this doesn't care what kind of strawberry it is. This 1600 didn't care what the concentration was. It's just pure the boxes, okay? But then it said standard, these X's sell for $7. So if I go $7 times X plus these sold for $10 plus $10 times Y. See, up here I did a percent. That's like a weight. And up here I did a value. That's like a weight of different costs. And I need a total amount. Well, here I did percent times the total. I don't know a percent, but I do know the total value, $1,110. Think about this. $7 times number of boxes. This is going to be dollars I got from the regular strawberries, dollars I got from the deluxe. There's my thing. Now check this out. If I was going to multiply -7 times each of these, that's going to give me -7x minus 7y equals, what's 7 times 135? -945. And then here's 7x plus 10y equals 1110. X's are gone. 10 minus 7 is 3y equals minus, I'm just doing 1110 minus 945, 165. Divide that by 3, and I'm going to get 55. Means I sold 55 deluxe boxes. And if I sold 135 total, 135 minus the 55 gives me 80. So this is 80 boxes. Cool. Okay. Now. Whew. Okay, so for the next thing, guys. Now, the next. I kind of clumped this in one. I never taught you how to do these without using matrices because I knew this is going to happen. Feel free to use matrices. I just taught you to use matrices because we've done row operations like this in Math 3 and 1010. So here's what I'm going to do. I'm going to actually solve all of these with row operations. And then when I get over here, I'm going to actually do this. I'm going to do this with something else. Maybe I'll do Kramer's rule. Okay? So I'm going to solve row operations with all of these. So this tells me solve them using elimination. So I'm going to do this. First, translate them into matrices. This one, 2x minus 3y minus z equals 0. So 2, -3, -1, 0. My next row, 3, 2, 2, 2, 3, 2, 2, 2. And this one, 1, 5, 3, 2. 1, 5, 3, 2. Okay, now I'm going to check 2, 3, 1. 2, 3, 1, check. -3, 2, 5. -3, 5, check. -1, 2, 3. -1, 2, 3, check. 0, 2, 2. Okay, I'm going to solve these. I'm going to come back and solve these. Now, I'm looking for a 0. Now, I don't count that 0 because it's in the answer column. I'm looking for a 0 over here. I don't have one. Where could I make one? So numbers are all different. These are all different. These are all different. But I'm looking. You know what? I'm going to get 0 right here. So I'm going to multiply -2 times that third row. That will make that into a -2. And then if I add it to the first row, that'll eliminate that. So, and I'm going to do that in my head. So -2 times 1 is -2, plus 2 is 0. Here, -2 times 5 is -10. -10 plus the -3 is -13. -2 times 3 is -6. -6 plus the -1 is -7. -2 times 2 is -4. -2 plus 0 is -4. Okay, now everything else just comes right in here. 2, 5, 2, 3, 2, 2. 2, 2, 2, 3, 2, 5, 3, 1, check. Okay, now I got a 0 right here. I need to get a 0 somewhere else. And I'm thinking, you know what? I could do the same thing, except I could multiply -3 times that and add it to that. So -3 times that third row, and I'll add it to the second row, because -3 times 1 is -3 plus 3 is 0. So let's look at this. We've got 0, -13, -7, -4, 1, 5, 3, 2. Okay, so -3 times 1 is -3. -3 plus 3 is 0. -3 times 5 is -15. -15 plus 2 is 13. Ooh, I like this right here. See what's going to happen? -3 times 3 is -9, and -9 plus 2 is -7. Huh. Okay. -3 times 2 is -6. -6 plus 2 is -4. Okay. Now, I'm seeing what's going to happen here, because see, if I look at this, I know that I can add these together and it's going to eliminate these. So I'm going to just add row 1 and row 2 together and make a new row 1. So I'll look at that. 0 plus 0 is 0. 13 plus the -13 is 0. -7 plus -7 is -14. And -4 plus a -4 is -8. Okay, now the reason I don't like that is because all of a sudden I've got -14z equals -8. So z is equal to -8 over -14, which is 8/14, which reduces to 4/7. Okay, so z is 4/7. Now, fractions aren't necessarily evil, but if I get a fraction that's not really pretty like that, like halves, thirds, things like that, I start to question if I've done something. So I'm gonna go back and check my work. That's one reason I do this. Check two. I'm gonna check it. Did I write it down right? 2, 3, 1, -3, 2, 5. Check. -1, 2, 3, 0, 2, 2. Okay, that's good. And then I did -2 times this plus the row, first row. -2 plus 2 is 0. Okay, -10 minus 3, -13. Okay, -2 is -6 minus 1, -7. Okay, -2 times 2 is -4 plus 0 is -4. Okay, check. So that worked out. 3, 2, 2, 2, 1, 5, 3, 2. Everything's good. -3 times this third row and add it to there. -3 times 1 is a -3 plus 3 is 0. Check. -3 times 5 is -15 plus 2 is 13. Check. -3 times 3 is -9 plus 2 is -7. Check. -3 times 2 is -6 plus 2 is -4. Check. And then I just added these together. Those were gone. This makes -14. Okay, so far everything is looking really good. I believe that's right because I double checked my answer. Now, if it's me, I'm just going to step back here and I'm going to pick something like 13y, like this second row. No x's, 13y minus 7z, and z is 4/7 equals -4. Okay, I'm just going to add 7 times 4/7, whatever that is, to each side. That's going to be gone, and 13y is equal to -4 plus 4/7 gives me -24/7. And if I divide by 13, divided by 13, that gets me y equals -24/91. Ooh, I don't like that at all, because that looks really, really ugly for a second. But I double checked my work for a little bit. So, wow, I swear I've missed something, because I don't really like that at all. So, because I get these ugly fractions like this, and I really start to doubt something. So I'm going to now triple check. Have I done something wrong? Because I'm expecting answers that are nice, pretty numbers. Because I know how math teachers will make that. Okay, so, 2, 3, 1, check. -3, 2, 5, okay. -1, 2, 3, -1, 2, 3, and 0, 2, 2. So that's copied. And this doesn't look right. This, I'm expecting, when these are here, I'm thinking maybe this should cancel or something. Did I make a mistake? -2 times row 3. -2 times 1 is -2. -2 plus 2 is 0. Okay. -2 times 5 is -10. Negative is -13. Check. -2 times 3 is -6. -6 plus that's negative. Check. -2 times 2 is -2. Plus 0 is -4. Okay. And everything else should have stayed, and it does. Okay. -3 times this. -3 times 1 is -3 plus 3 is 0. -3 times 5 is -15 plus 2 is -13. There's where I made my mistake. Crud. So look at this. If I do this, it's not going to cancel. But if I change the signs, so some of you are probably screaming. In fact, all of you are probably screaming, Dick, you made a mistake. So now I want to cancel these. I'm going to change these signs. So this makes, I'm going to come over here, and I'm going to combine this by changing these signs and adding here. So -13 is 13 plus minus 13. So I've got 0, 0. Opposite of -13 plus 13 is gone. Opposite of -7 is 7. 7 minus 7 is gone. Opposite of -4 is 4. Plus or minus 4 is gone. See that? I got zeros. Zeros mean that there are infinitely many solutions. Okay, infinitely many. Now, a couple of things. See how easy it is to make a mistake. I missed a negative. Crud. But here's something that I think you all should do. If I'm getting fractions like this that are not pretty, like 1/2, 1/3, 1/4, but even that, I would always go back and question. And I double checked myself twice, and the second time I caught it. Okay, infinitely many solutions. Okay, so I apologize for that. Let's look at something else. B is right here. So let me copy it down. I'm going to write a matrix. -2x, 2y, -3z is equal to 4. -2, 2, -3, 4. Check. 1, 2, -1, 3. 1, 2, -1, 3. Okay, and then 2, -4, 1. 2, -4, 1, -7. Okay, let me check here. 4, -3, -7. Oops, I missed that negative. So triple check. 4, -3, so -7. Okay, -3, -1, 1. -3, -1, 1. Okay. 2, 2, -4. 2, 2, -4. Okay. negative 2, 1, 2, negative 2, 1, 2. Okay, check. It's worth double checking your system. If you write down the wrong system, of course you're not going to write the solution. So let's solve that. I'm looking at this. Hey, these two, if I add it together, if I just add these two rows together, negative 2 plus 2 makes 0. 2 plus negative 4 make negative 2. Negative 3 plus 1 make negative 2. 4 plus negative 7 makes negative 3. Okay? Make sure I wrote it down. 1, 2, 1, okay. 2, negative 2, 2, negative 3. Okay. Okay. Now, I want a 0 in that same column. I'm looking at if I double this and add it here, so if I go 2 times that second row and I add it to the first row, I can make a new first row. Cool. Now, in doing this, if you're thinking of something else, try it. You should all end up with the same solution. So let me write down the rest of this. Okay. 2 times 1 is 2, plus the negative 2 is 0. 2 times 2 is 4, plus 2 is 6. 2 times negative 1 is negative 2, plus the negative 3 is negative 5. 2 times negative 3 is negative 6. Negative 6 plus 4 is negative 2. Okay, cool. Now, you know what? If I multiply this by 3, I'll get 6. I multiply it by a negative 3, so negative 3 times that second row, and I add it to the first row. I can need another first row. Okay, so cool. I like this. Wait a second, I don't want to do that because that will dummy, 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 dummy. Dummy, dummy, dummy. Oh, but see, the whole reason, and that's an easy trap to fall into, the whole reason we made zeros on top of each other here and here is so that I can combine that row and not fill in that 0. See, that would have filled in the 0. But look, negative 2 to 6, if I multiply that third row by 3, 3 times negative 2 is negative 6. It'll wipe that out. Okay. So the middle row, that's not changing. 1, 2, negative 1, negative 3, negative 1, negative 3. Bottom row ain't changing. 0, negative 2, negative 2, negative 3. Okay. 3 times 0 is 0 plus 0 is 0. Good. 3 times negative 2 is negative 6 plus 6 is 0. 3 times negative 2 is negative 6 plus the negative 5 make negative 11. 3 times negative 3 is negative 9 plus the negative 2 is negative 11. So now I have negative 11z equals negative 11. Hey, I can even do that. Z is 1. Okay? Now check this out. See this third equation? It's negative 2y minus 2z is equal to negative 3. And z is 1. So I'm just going to put a 1 in there. So negative 2y minus 2 times 1 is negative 2 equals negative 3. And if I add 2 to each side, negative 2y equals negative 3 plus 2 is negative 1. Divide by negative 2, and I get positive 1/2. It's a fraction, but it's not an ugly fraction. So I'm kind of okay with that. Okay? Now, I'm going to solve, excuse me. I've got z, I've got y, I need x. Where can I find x? Oh, look, I got an equation with an x in there. So 1x plus 2 y's, and y is 1/2. Ooh, this makes me feel better. Because see, 2 times that 1/2, it's going to be a nice whole number. So I'm happy again right now. Minus z, and z is 1, equals negative 3. So I looked at this equation right there, and I just put x, y, and z, right? X, y, z, except I knew y and z. So this is x plus 1 minus 1 equals negative 3. Hey, those cancel, and I get x equals negative 3. And there are my solutions. Cool. Cool, cool, cool. Okay. Let's look at 10C. Let's look at 10C. which if I copy that down right from here, I end up get -1, 2, 5, 4. And I get 1, 0 y's, -2z, and 0. Okay, and here I get 4, -2, -4, -2, -11, 2. Okay, cool. Double checking myself. -1, 1, 4, check. 2, 0, -2, check. 5, -2, -11, check. 4, 0, 2, check. Okay, I got it. Okay. I see a 0 right here, but see, I can add these together. So if I add together the third row plus the first row, let's make a new first row. So 4 plus -1, that's 3. -2 plus 2 is 0. -11 plus 5 is -6. And 2 plus 4 is 6. And I have 1, 0, -2, 0 here. 4, -2, -11, 2 there. Okay. Now I'm looking at this. I need to work with these two rows because they have the 2 zeros. If I do -3 times that second row, -3 times 1 is -3, and add it to there, I'll get a new row 1. Okay. So 4, 1, 0, -2, -2, -11, 0, 2. So -3 times 1, -3 times 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 0 is 0. -3 times -2 is 6, plus -6 is 0. Really? I guess so. -3 times 0 is 0, plus 6 is 6. Check this out. 0 equals 6. That's not true. This has no solutions. Okay, so wow. Did we have oh no, this one had one solution where it was 1 point. It would have been like -3, 1/2, and 1. Whether you express your answer like that or just as X, Y, Z's like that, that's fine. This one had no solutions, and the other one had infinitely many. Okay, so we got all three there. Okay, guys, I'm going to stop there and move on to another set of problems. So, guys, that's it. Look forward to the next set. See ya.